Hi, today I'm going to be teaching you how to prototype your designs using the Proto POD. This is the first part in a series entitled Dronesmiths. Pods are plug-and-operate devices that allow for additional functionality development. Pods attach to Quark through the bottom of the drone through our CubeSat header. Pods expand the capabilities of Quark for widespread use in a variety of applications. Before we start developing with the Proto POD, prior knowledge of soldering and electronics design is recommended. If you're looking for a place to start, MIT, Stanford, as well as Khan Academy and YouTube offer various videos on electronics design. Included in every purchase of Quark is a prototype pod. Prototype pods are laid out like traditional breadboards for ease of development. Included on the Proto Pods is a 5-volt line capable of supplying 5 amps, a 3.3-volt line capable of supplying 300 milliamps, and a battery voltage line capable of supplying 3 amps. Also on the Proto Pod are SPI, I2C, and UART serial communication lines, as well as a CAN bus and 2 ADC pins. Each Proto Pod comes with an EEPROM chip to identify and provide storage for important data about the pod. When choosing between the 3 serial communication protocols provided, keep this in mind. We prefer I2C because of its ease of use in stacking pods. For more information about the serial lines, see the documentation link below. The first step in developing with the Proto POD is to choose a microcontroller. We commonly use Atmel Atmega chips, such as this one, because of the ease of use and fast prototyping that can be done through the Arduino IDE. ST Microelectronics and Texas Instruments provide a variety of microcontrollers in both size and speed, as well as the functions they provide. The next step in the development process is to write the software for the microcontroller. Stay tuned for the next episode for an in-depth look at how to write software using the Arduino IDE. After the software is written, the next step is to lay out the components on the Proto POD. For the rest of this video, I will take you through a sample design and how to implement the design using the Proto POD. Here I have laid out a simple gas sensor design that runs on 5 volts power. The gas sensor provides an analog voltage output that is then read by the Atmega 328P, which is then internally processed and sent to Quark through the I2C, data, and clock lines. Here I'll be laying out the schematic on a traditional breadboard attached to an Arduino Uno. First, I'm going to plug in the 5-volt power line to the power supply rails on the breadboard. Next, I'm going to attach the ground from the Arduino to the ground rail on the breadboard. Next, I'm going to attach the load resistor across the output for the gas sensor. Next, I'm going to attach the ground from the gas sensor to the ground rail. Then I'm going to plug the gas sensor into the power rail. Finally, I'm going to plug the analog out from the gas sensor into A0, which is an analog input on the Arduino Uno. Now that we've laid it out on a traditional breadboard, let's transfer this design to the Proto POD. The next step, as I stated before, is to lay out the components on the Proto POD before soldering. Since I can't solder jumper wires, I'm going to have to cut some of my own. Now that I have some wires cut, let's go ahead and start laying out the components on the Proto POD. The first step is to transfer the gas sensor from the traditional breadboard to the Proto POD. I've already placed a header to space the gas sensor above the Proto POD so it's easier to connect everything. Next, I'm going to power the gas sensor from the 5-volt line on the Proto POD. Next, I'm going to attach the gas sensor to ground. Next, I'm going to take the 10K resistor from the breadboard and place it on the Proto POD. Remember that I have to attach the other side of the resistor to ground. Next, I'm going to attach a wire that's going to be my output line that's running to my Arduino. For the purposes of this video, I'm going to leave my Arduino unattached from the Proto POD. Even though I'm going to leave it unattached, I still need to power the Arduino Uno, as well as attach the I2C lines to the I2C lines on the Proto POD. On the Arduino Uno, the A4 line is data and the A5 line is clock. So I'm going to attach the A4 line to the data line on the Proto POD. I'm going to attach the clock line, which is A5, to the clock line on the Proto POD. Now I'm going to power the Arduino Uno through the VN line and attach it to the 5-volt line on the Proto POD. Then I'm going to attach the ground to the ground on the Proto Pod. Keeping in mind how I laid out the components on the proto board the first time, now I'm going to solder the components to the proto board. Now that I've finished soldering the simple design, it's ready to be plugged into Cork and flown. Now let me show you what it would have looked like if I'd attached the Arduino to the proto pod. The only difference between this proto pod and the one currently attached to Cork is that this is an Arduino Mini, so it's just a smaller version of the Arduino Uno with a couple of slight differences that aren't worthwhile mentioning here. And this one has a buzzer that goes off when gas is detected. The only thing that's keeping this pod from being flight ready are 4 standoffs to keep it secure during flight and to allow for more pods to be stacked on top of it. Thanks for watching our informational video. Please subscribe to our channel for more videos and stay tuned for part 2 where we'll highlight software as well as I2C communication between the Arduino and Cork.